All right, today we're looking at Math 2, Unit 3, Lesson 2. This is Form K, which is what we're using currently at Buchanan High School. So today we're looking at proving triangle congruence by the side-side-side theorem or the side-angle-side. So here we go. Looking at the first one, this is going to teach you a little bit about how do we develop a proof in order to solve something here. We have some question marks, which is what we're going to be filling in the gap. If you remember from your lesson the other day, you had basically like the T-chart like this, where it had the given on one side and the reason on the other, and you have numbers this way. We'll have some more of those coming up, but this time they just put it as a flow chart to say, let's put the parts together and see what you end up. How do you get down to the point where you know that it's side angle side? All right, so first of all, they gave us Rx is congruent to Sx and Qx is congruent to Tx. So that information right there is given. So in this space here, we would simply say given. That's all there is to that. And then when we look at the triangle, because Rx here is equal to that and that, because those are the same, we know a couple of things. We know that's what's happening is these lines are bisecting one another. That's how you get those points there. It then says that QXR, this angle, is congruent to TXS, this angle. And we know that's true because vertical angles are congruent. So vertical angles are congruent, so that's true there. And as a result, knowing that we can have sides that are the same and angles in the middle because we have a side, angle, side, now we can say these triangles are congruent by side, angle, side. And that's kind of what we're working with today. Okay, so let's take a look then at number 2. It wants to know what other information, if any, do you need to prove the two triangles congruent by side, angle, side. And explain. It says to start, list the pairs of congruent corresponding parts you already know. So in this case here, it says AB, which is here, is congruent to, well, in this case, let's go with, I'm going to go with probably HG as we work up our way up that way. Let's go with HG. And it says BC going down is going to be congruent to, probably going to be GF. So while that might be all fine and dandy, I want to know some other information. What am I missing? It would be helpful if I knew what angle B and angle G were. Because if I knew that angle B was congruent to angle G, then I could say I can use the side, angle, side. I need that included angle. If I don't have the included angle, then I can't use the side, angle, side. It's not going to work. So I needed an included angle, and that wasn't in this problem. Okay? When I look over here at number 3, the same idea, and I'll let you do that one on your own. You're looking at the sides, write down what's congruent, angles, side lengths, and then see what you got. Okay, moving down to number 4. Number 4. It says, would you use side, 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 or side, angle, side to prove these triangles congruent? If there is not enough information, write not enough information and explain your answer. Okay. On this one, number 4, we have a side equal to this side equal to that side, and you say, well, I have two sides. There's no information about the angles, so I don't have any angle information I can really use here. But I do know that these two triangles share this line in the middle. So because they share that line, it is also going to be congruent with each other. So because of that, I have 3 equal side lengths. I would end up using, in this case, the side-side-side theorem, and the reason is because of the reflexive property of congruence. And I can write that as this if I wanted to as well. Curly thing there. Okay. So I use a reflexive property. They're sharing the same line. It's going to be the same length, so we're good to go. So I have a 1, 2, 3, 1, 2, 3. Yes, side, side, side would help me prove those are congruent. If I look at number 5, I have a triangle. I have a line segment that equals here and here. I have a line segment here, and here. So I'm in good shape. In terms of the information I would need to know, well, I know that vertical angles are also congruent. So because I know that, then I see that I have a side, I have an included angle, and a side. So I would use the side angle side, and the reason I would do that again is because vertical angles are congruent. And that's why I would use side angle side for that one. Let's look at the back side now. Looking at number 6. So this next part here, it's going to want you to use the distance formula. Recall that the distance formula, if I write it out for you over here, is going to be the square root of, and in parentheses, y2 minus y1 squared plus x2 minus, oops, sorry, I can do it backwards. Let's erase this here. And it really doesn't make a huge difference because you're going to square it, but let's, for the sake of what you learned in class, my apologies, we'll go y1 minus y2 plus x1 minus x2. Sorry about that again. See, in math you make mistakes, but that's why you have an eraser. Lucky me. Alright, so I'm going to use this formula to plug in various numbers here to determine the distance from point to point. And that's what this is for, to say how far is it from one point to the next. That's what you're doing here. So when I look, for example, at FG right here, I have the value of FG. F is at 0, 0. G is at 0, 4. So this is my x1, y1, x2, y2. When I plug y1 in, I have 0. There it is. When I plug y2 in, I have 4. x1 is 0. x2 is 0. And so 0 minus 4 is a negative 4. Negative 4 squared is 16. Alright, so negative 4 squared is 16 plus 0. So I end up with the square root of 16, essentially on this one here, which ends up being 4. Okay, we good so far with that? So basically we're just plugging in numbers and working them out to get what we need to get to. So we would say, okay, FG is 4. I'm good there. Alright, and then I'd have to say what JK is going to be. Now at this point, I don't know if this is all going to work out. I have 4 minus 4 is 0. So I can write a 0 right here. Plus 1 minus a minus 3. That's going to be 4 again. And 4 squared is 16. So I end up with a square root of 16, which is equal to 4. So looking at my triangle up above, with the order that matters, FG, this length right here, and JK, this length here, are both equal to 4. What you're going to need to do to continue this is to do the distance formula for GH, which is the second segment, and KL. And if those equal each other, then that's step 2. We know these are equal. We have one side equal. We want to see if the second side is equal, and then you'll do the same thing for the third side. If these match each other, and these, then you know that you'll have a congruent triangle, and you're good to go. And that's what number 6 is going to be. I'm going to let you work that out to determine if you have corresponding sides, and if yes, show your work and you're set. The same is true for number 7. It's just going to be a lot of math work to be able to prove that that is actually going to be true. So distance formula, just got to work that out again and again. It just takes some time. Okay? So I'm not going to do that because you can do it there yourself. All right, number 8. Wants to know, can you prove the triangles are congruent? If so, write the congruent statement and name the postulate you would use. If not, say not enough information. Okay, so for number 8, I have a side and an angle and a side, and it says it's congruent to a side and an angle and a side. So because I have an angle right there that is included, I can say that yes, these triangles are congruent, and that would be by the side angle side postulate. For number 9, when I look at number 9, while I might have 2 isosceles triangles here, and that matches that and that, I don't see any angles. No angles are available. Because I don't have any angles, they might look the same. I don't have not enough information. If they gave me these angles, then I could use side angle side, but they didn't. If they gave me this side length here, then I could use side, 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 but they didn't. So I have to say in this case, not enough information. So I can't do anything else there. Okay, looking at number 10. Almost done here, guys. Two more. It says, suppose AB is congruent to DE, and angle B is congruent to E, and AB congruent to BC. Is ABC congruent to DEF? That's a lot of blah, blah, blahs. So I'm going to write this out and draw a little picture. Okay? So here's what I did. I said, if line AB is congruent to DE, and angle B, we'll make this angle B, is congruent to angle E. Okay, I'll make my hash marks there. And then AB, there we go, AB is congruent to BC. So let's call this point right here C. And we're saying that matches that. Is triangle ABC congruent to DEF? Well, I don't know. And the reason I don't know is I don't know what this line's going to be. They didn't tell me that that one equaled that one. So because I don't know what E, in this case EF, is equal to, I don't know if they're going to be congruent. I would need to know what EF is equal to. If they told me it was congruent to ED, then yes. But they didn't, so I have to say not enough information is given to me this time. Okay, let's take a look at our last one. It's another proof question. All right, so these are important. You have lots of these coming up again in this unit. First, it gives me information. It says that BD is the perpendicular bisector of AC. By saying that, it's telling me that it's making a perpendicular angle here, which means I have a 90-degree angle. And because it's bisecting, I have two line segments, AD and DC, that are congruent to one another. That's the information that they provide me with at the start of the problem. Now, what's nice is they do give you some information to kind of guide you along. So first, they start with the given. BD is perpendicular bisector, given. AD here is congruent to CD, and that's the definition of a segment bisector. So once it bisects, by definition, those are equal. ADB and CDB are right angles, which we have here, and I can add another one there. That's the definition of being perpendicular. And now it says, well, I want to prove that triangle BAD is congruent to triangle BCD. Again, this lesson, think about it, we're working with side, 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 or side, angle, side. That's kind of what we're working with here. When I look at this triangle, I can see that I have a side and an angle that matches a side and an angle. I need another side is what I really need here. Now, how can I do that there? Well, first of all, let's start here with our next step. All right, we said that these are right angles. One of the steps they want you to add, and this is where it's a little tricky for me with proofs. I kind of think, doesn't everybody know that? But I guess they like you to show your work. I need to at least state that triangle ADB is congruent to triangle CDB. We said in step 3 that they were right angles. We defined them. Well, it's implied that they are both 90 degrees and they're both equal, but I have to state it in a proof. I can't just say that they're both right and leave it. I need to say that they also are congruent. So the reason for that is all right angles are congruent. So it seems simple enough, and that's just a basic thing. So all right angles are congruent, and there we go there. Okay. The next thing I want to say is I want to say that this line is equal on both triangles. So line segment BD is congruent on one triangle to line segment BD of the other triangle. So this BD of the lower triangle is the same BD as the upper triangle. And the reason for that is the reflexive property of congruence. And that's how that works there. So if that's true, now I have another line. At this point, I have a side, an angle, and a side. So I can make my final statement. My proving part is always my last part. Triangle BAD is congruent to triangle BCD. And the reason I know that is by the side, angle, side postulate. All right, and that's it for today's lesson. Thanks.